I kept seeing the same claim show up everywhere online. A Chinese operating system that supposedly runs an entire desktop on just 1.6 gigabytes of RAM, less memory than most phones carry in your pocket right now. So I downloaded it myself, installed it on real hardware, and watched the actual numbers with my own eyes. What I found wasn't quite the fairy tale the headlines promised, but it was honestly more interesting than the original claim itself. The system in question is called o.mp4, and if you've never heard of it, you're not alone. It's China's first fully independent, open source desktop operating system, built by a company called Soft, which itself sits under a much larger state-owned firm, China Electronics Corporation. This isn't some random hobbyist project uploaded by one developer in their spare time. Nearly 4,000 developers, over 70 special interest groups, and more than 270 companies have contributed to building it from the ground up. To actually understand Opinkalin, you need to go back more than 2 decades because this project didn't appear out of nowhere in 2023. The Kylin name itself traces back to 2001 when academics at China's National University of Defense Technology, an institution with direct ties to the People's Liberation Army, began building a domestically controlled operating system explicitly designed to reduce dependence on foreign software inside military and government computers. The earliest versions weren't even based on Linux. They ran on a modified FreeBSD kernel, and the project carried a level of secrecy you'd expect from something developed alongside a military research institute. That secrecy actually backfired in spectacular fashion back in 2006. An anonymous Chinese student studying in Australia, posting under the pseudonym Dancefire, ran a detailed kernel comparison and found a 99.45% similarity between Kylin's supposedly original code and standard FreeBSD. One of Kylin's own developers eventually admitted as much publicly at an international conference that same year. What was originally marketed as a fully homegrown, independently engineered operating system turned out to be leaning enormously on existing open-source FreeBSD code underneath the surface, a controversy that became known afterward simply as the Dancefire incident. Whether that early embarrassment played a role or not, Kylin underwent a complete architectural overhaul in 2010, abandoning FreeBSD entirely in favor of the Linux kernel. That same year, a new enterprise-focused variant called Neocolin was announced, developed through China Standard Software, and this version is where the story starts getting genuinely strange. Neocolin's user interface didn't just resemble Windows in passing. It was, by most independent accounts, an almost direct visual copy of Windows XP, right down to the layout of icons, menus, and system dialogues. That specific design choice makes a lot more sense once you understand the timing. Microsoft ended support for Windows XP just as a huge portion of Chinese government computers, reportedly over 20% at the time, were still running it daily. When Microsoft pushed everyone toward Windows 8 instead, Chinese officials weren't thrilled, and tensions only escalated further once Edward Snowden's leaks about American surveillance programs went public, fueling serious concern inside Beijing about exactly what might be hiding inside foreign-built operating systems running on sensitive government hardware. China's response was blunt. Government offices banned Windows 8 outright, and Neocolin, deliberately built to feel instantly familiar to displaced Windows XP users, was waiting right there as the approved replacement. The actual adoption numbers behind Neocolin are honestly staggering once you start digging through them. By 2014, the northeastern Chinese city of Siping had already migrated its entire municipal computer fleet away from Microsoft Windows and onto Neocolin, part of a broader coordinated government effort to shift critical infrastructure toward domestic suppliers. The following year, Dell publicly confirmed that 42% of the personal computers it shipped inside China came pre-installed with Neocolin rather than Windows, a number that should genuinely surprise anyone who assumed Microsoft held an unshakable monopoly across the entire Chinese PC market. By 2019, Neocolin had grown compatible with over 4,000 separate hardware and software products, and combined with its sibling Kylin variant, The two together commanded roughly 90% of China's entire government sector market share. Even China's Tianhe-1 and Tianhe-2 supercomputers, machines built for serious high-performance scientific computing, run on Kylin Linux rather than anything sourced from the West. Then in 2013, the story took yet another turn. Canonical, the company behind mainstream Ubuntu, reached a formal agreement with China's Ministry of Industry and Information Technology to co-develop an entirely separate flavor called Ubuntu Kylin, specifically localized for Chinese users. This wasn't simply a translated version of regular Ubuntu. It shipped with its own custom desktop environment called Dukui, forked from the older Mate desktop, along with deeply integrated Chinese-specific tools, including a dedicated Sogu input method for typing Chinese characters efficiently, lunar calendar integration, and an entire suite of in-house utilities branded under the name Yauker. Crucially, Ubuntu Kylin defaulted to WPS Office instead of LibreOffice in its enhanced editions, the same Chinese-built productivity suite that would later carry straight through into o.mp4 itself, maintaining a thread of continuity stretching across more than a decade of separate but clearly related projects. Before installing anything, I wanted to understand why this specific operating system exists in the first place, because the backstory matters just as much as the benchmark numbers. China has spent years pushing to reduce its reliance on Western software, especially after watching how quickly geopolitical tensions can turn ordinary software licenses into leverage. o.mp4 launched its first stable release back in 2023, explicitly framed as a step toward technological self-reliance, not just another Linux distribution competing for hobbyist attention. The project itself was first publicly announced back in 2022. Backed at launch by close to 24 Chinese firms and research institutions, including China's own Advanced Operating System Innovation Center, well before the first stable build ever reached the public. So I grabbed the latest available image, burned it onto a USB drive, and installed it the same way I'd install any other Linux distribution. The desktop that greeted me afterward is called Dukui, and visually, it leans heavily toward a layout that feels instantly familiar if you've ever used Windows. Taskbar at the bottom, Start Style. Menu in the corner, System tray on the right. Nothing alien here. Which honestly makes sense if your target audience includes millions of government workers transitioning away from Windows for the first time in their careers. Now here's where things get genuinely interesting, because the moment I opened a terminal and checked memory usage right after boot, my numbers didn't match the viral 1.6 gigabyte claim at all. My fresh install, sitting completely idle with nothing open, was pulling closer to 2.3 gigabytes of RAM, still impressively light by modern standards, but noticeably higher than the number everyone keeps repeating online. Curious whether I'd done something wrong, I went digging through other independent tests to see if my results were an outlier or part of a wider pattern. What I found genuinely surprised me. One particularly thorough reviewer, testing o.mp4 specifically for resource efficiency, reported the system consuming somewhere between 2.32 and 2.35 gigabytes of RAM at idle, paired with disk usage stretching past 13 gigabytes for a full default install. That matched roughly what I'd seen myself. But then I found a completely different test from someone who runs exclusively free and open source software as a matter of principle, who reported something that nearly knocked me out of my chair. That reviewer measured o.mp4 consuming 6.5 gigabytes of RAM straight after a fresh boot, calling it the single heaviest Linux distribution they had ever personally tested, in the same breath as comparing it directly to Windows 11e's notoriously bloated footprint. After spending a full hour manually disabling features and stripping back customizations, the absolute best they could manage was bringing it down to 2.8 gigabytes, still nowhere close to the 1.6 gigabyte figure circulating online. If three completely different testers can produce three wildly different numbers testing the exact same operating system, that should tell you something important about how these viral claims actually spread in the first place. Smash that like button right now if you've ever seen a tech claim online that turned out to be way more complicated once someone actually tested it themselves, because that's exactly the rabbit hole I fell into here. To put these numbers in proper context, I also pulled up RAM figures from a few genuinely lightweight Linux distributions that have built their entire reputation around minimal resource usage. Tiny Core Linux, a distribution stripped down to its absolute bare essentials, can run a functional graphical desktop using somewhere around 50 to 150 megabytes of RAM, an almost absurd figure by modern standards. Antics, built specifically for genuinely old or low-powered hardware, typically idles somewhere in the 200 to 300 megabyte range. Even Linux Mint running the lighter XSE desktop environment. A distribution most people would call comfortably lightweight rather than extreme, generally settles around 400 to 700 megabytes at idle on a typical modern install. Stack o.mp4's real-world 2 to 2.5 gigabyte range next to those numbers, and the picture shifts noticeably. o.mp4 isn't competing in the same weight class as those genuinely minimal, stripped-down distributions at all. It's running a full, modern, visually polished desktop environment loaded with built-in applications, multi-device features, and a complete software ecosystem, which makes its memory footprint considerably more comparable to mainstream consumer operating systems like standard Ubuntu or Windows than to anything purpose-built purely for squeezing onto ancient hardware. So where does the 1.6 gigabyte number actually come from? After digging through o.mp4's official documentation, I found the most likely explanation, and it's genuinely clever engineering, even if the marketing around it oversimplified things. o.mp4 includes a built-in feature called Graded Freeze, a custom-built application lifecycle management system designed specifically to squeeze more performance out of limited hardware, instead of letting every open application sit fully active in memory regardless of whether you're using it. Graded Freeze actively monitors which apps you're currently interacting with and which ones are just sitting forgotten in the background. Anything you're not actively touching gets progressively frozen, freeing up CPU cycles, disk input and output, and yes, memory. Specifically so your currently active task gets priority access to whatever resources the hardware actually has available. The system reportedly works across multiple distinct stages rather than a simple on-off switch. A background application first gets throttled, limiting how much processing time it receives before progressing toward a deeper freeze state where its memory pages can be more aggressively reclaimed by the system. This kind of staged approach mirrors techniques mobile operating systems have used for years to stretch limited battery life and memory on smartphones. Adapted here specifically for a desktop environment where users are used to leaving a dozen windows open simultaneously without thinking twice about it. It's a genuinely sensible piece of engineering for hardware-constrained environments, even if it doesn't magically shrink the baseline footprint of the operating system itself sitting fully idle with nothing else competing for resources. In other words, that 1.6 gigabyte figure almost certainly reflects a very specific, very minimal configuration. Maybe a stripped install with aggressive freezing already kicking in, maybe an older or lighter version of the desktop environment, maybe a test environment with practically nothing running beyond the absolute bare essentials. It's not necessarily a fabricated number. It's a best case number, dressed up online to look like a typical, everyday result. This is honestly such a familiar pattern in tech marketing that it almost feels like a rule at this point. The most impressive number from any benchmark sheet becomes the headline, while the messy, inconsistent reality buried underneath gets quietly left out of the conversation. o.mp4 isn't unique in doing this. Plenty of operating systems and devices have leaned on their most flattering possible numbers, while real-world testing reveals something considerably less dramatic. But here's where I want to push back against the temptation to just call this whole thing a marketing gimmick and move on. Because there's something genuinely impressive buried underneath the inflated headline number. o.mp4 officially supports 3 completely different processor architectures right out of the box. Standard x86 chips that power most Windows laptops, ARM processors found in everything from Raspberry Pi boards to modern smartphones. and RISC-V, an open instruction set architecture that China has been investing in heavily as part of its broader push toward semiconductor independence. Understanding why RISC-V matters this much requires zooming out to the broader chip war that's been quietly reshaping global technology policy for years now. Both x86 and ARM architectures sit under licensing structures controlled by companies headquartered in the United States and the United Kingdom, respectively, meaning any country building chips on either foundation remains permanently exposed to export restrictions, sanctions, or licensing disputes outside its own control. RISC-V flips that arrangement entirely, since its instruction set is openly published and free for anyone to implement without paying licensing fees or seeking permission from a foreign gatekeeper. China has poured enormous resources into RISC-V specifically because it represents one of the only realistic paths toward chip designs that remain fully insulated from future export controls, regardless of how geopolitical relationships shift in the years ahead. I actually found documented test logs of o.mp4 running successfully on a RISC-V development board called the o.mp4, executing real workloads on hardware that has zero dependency on x86 licensing or ARM's intellectual property restrictions. For a country actively trying to reduce its reliance on foreign chip designs, having a fully functional desktop operating system that already runs natively on a homegrown instruction set architecture is a considerably bigger deal than any single RAM benchmark number. And this is exactly where the story stops being about one operating system and starts connecting to something much bigger happening globally right now. If you watched my previous video about Windows facing a genuine exodus in 2026, you already know European governments have started mandating large-scale Linux migrations specifically to escape dependence on American software companies. China has been running its own version of that exact same playbook for years, just with considerably less international media attention focused on it. If that connection just clicked for you, subscribe right now, because the parallels between what's happening in Europe and what's already been quietly happening inside China for years longer are honestly wild once you start digging into both stories side by side. o.mp4 isn't China's only homegrown operating system effort either, and understanding the wider ecosystem makes the bigger picture click into place. Neocolin, the older and more enterprise-focused sibling project we touched on earlier, has continued evolving well past its Windows XP mimicking origins, with a newer release called Neocolin V11 arriving in 2025 running a considerably more modern Linux kernel. It remains deployed across Chinese government offices and state-owned enterprises, running on custom systems, energy infrastructure, and financial institutions where data sovereignty concerns run especially deep. Uniontech, another major Chinese software company, builds its own UOS platform, closely related to the deep-in desktop environment that's become one of the more polished and internationally recognized Chinese Linux distributions among hobbyists outside China entirely, known for an interface that frequently gets praised even by Western reviewers as one of the more visually refined desktop experiences in the entire Linux world. Here's a number that genuinely stopped me while researching this video. Kylin and Neocolin combined reportedly command roughly 90% of the entire Chinese government sector's operating system market, 90% in a country with well over 1 billion people and a government bureaucracy of staggering size. The operating system most people outside China have never even heard of is the dominant choice running underneath the desks of actual government employees every single day. If that number genuinely surprised you, that's exactly the reaction this video is built around delivering. So go ahead and subscribe right now if you want more breakdowns digging into operating systems and tech ecosystems most casual viewers never even knew existed. And then there's Huawei's Harmonious, arguably the most ambitious piece of this entire puzzle. Originally built as a flexible operating system capable of running on devices using anywhere from a mere 128 kilobytes of memory all the way up past 4 gigabytes, Harmonious has steadily expanded from simple smart devices into powering Huawei's actual flagship smartphones. tablets and laptops completely independent from Android's underlying codebase. China isn't just building one alternative operating system as an experiment. It's building an entire layered ecosystem of alternatives, spanning everything from tiny embedded sensors all the way up to full government desktop deployments. What makes this entire ecosystem strategy genuinely different from a typical hobbyist open source movement is the deliberate coordination behind it. These aren't competing projects fighting for the same narrow slice of users, the way rival Linux distributions in the West often do. Neocolin secures the high-security government and military space. Ubuntu Kylin and o.mp4 target broader desktop adoption among ordinary users and smaller businesses. UOSAN deep in chase a more polished, internationally palatable aesthetic. Harmonious covers mobile devices, smart appliances, and increasingly laptops too. Each project occupies a distinct lane, and together they form a surprisingly complete vertical stack, covering nearly every category of device a modern economy actually depends on. Stop and think about the scale of that ambition for a second. While most casual tech conversations online stay fixated on whether Windows or macOS is slightly better for everyday tasks, an entire government-backed software ecosystem has been quietly built from absolute scratch, specifically designed to function without depending on a single line of American-controlled code anywhere in the stack. This ambition obviously didn't emerge in a vacuum either. It's directly alongside an equally aggressive push toward semiconductor self-reliance, export-controlled chip restrictions from Washington, and a broader strategic anxiety running through Chinese industrial policy about depending on any foreign supplier for technology considered critical to national infrastructure. Software independence and hardware independence have effectively become two halves of the exact same long-term strategy, and o.mp4's support for RISC-V chips sits precisely at the intersection of both efforts simultaneously. That context completely reframes how I think about my own o.mp4 test results. Sure, the real-world RAM numbers I measured didn't match the viral marketing claims circulating online, but getting hung up purely on that discrepancy almost misses the much bigger story sitting right underneath it. This is a fully functional, actively developed desktop operating system built by thousands of contributors, running across three completely different processor architectures, specifically engineered to reduce a nation's dependence on foreign technology companies at a truly massive scale. Let's talk about the actual user experience for a moment, because raw memory benchmarks only tell part of the story anyone considering an actual switch would care about. o.mp4 ships with Firefox as its default browser and WPS Office as its productivity suite, a Chinese-developed alternative that maintains impressively strong compatibility with Microsoft Office file formats. Something genuinely critical for any organization migrating away from Windows without wanting every existing document to break in the process. The built-in software store felt reasonably polished during my testing, though I'll admit plenty of application descriptions remained untranslated into English. A reminder that this entire ecosystem was clearly built with its domestic Chinese audience as the primary priority, with international users very much an afterthought. I also want to be completely transparent about something that matters here. Testing an operating system built specifically around a different country's technological priorities means encountering design decisions that won't always make sense through a Western lens, and that's a completely normal and expected part of testing software built for a different primary audience. o.mp4 supports built-in multi-device collaboration tools designed specifically to interconnect with Android devices, screen sharing features, and cross-device file synchronization baked directly into the operating system itself, reflecting priorities and use cases that are clearly shaped around China's specific hardware ecosystem and how people there actually use their devices day to day. Coming back to the core question driving this entire test, is o.mp4 actually lightweight compared to mainstream alternatives? Compared to a heavily loaded Windows 11 installation, which one community benchmark thread measured idling around 3 full gigabytes of memory consumption on otherwise comparable hardware. o.mp4 in its more typical real-world configuration genuinely does come out ahead. 2.5 gigabytes of idle RAM usage is still a meaningfully lighter footprint than what Windows 11 demands before you've even opened a single application. It's just nowhere near the dramatic 1.6 gigabyte headline that originally sent me down this entire rabbit hole in the first place. If you've made it this far, here's the honest takeaway I walked away with after spending real hours testing this myself. Viral tech claims almost always carry a kernel of genuine truth buried somewhere inside them, but that truth usually gets stretched, simplified, or cherry-picked along the way until it barely resembles typical real-world performance anymore. o.mp4 genuinely is lighter than Windows 11 in most practical, everyday scenarios. It genuinely does run across 3 completely different processor architectures, including hardware built entirely outside the traditional x86 and ARM ecosystem, and it genuinely does represent a much larger, considerably more ambitious push toward full technological independence than most casual viewers outside China probably ever realized existed. What it isn't, at least based on everything I personally tested and every independent source I could track down, is a magical 1.6 gigabyte miracle system that somehow outperforms every other operating system on the planet using barely any memory whatsoever. The real story sitting underneath that viral claim turned out to be considerably more nuanced, considerably more geopolitically significant, and honestly, considerably more interesting than the original headline ever gave it credit for. If this kind of deep dive into testing viral tech claims against real-world results is exactly the content you want more of, that reaction is precisely why this channel exists. Drop a comment letting me know which other viral tech claim you want me to actually test myself next, because there's no shortage of wild numbers circulating online that genuinely deserve a second look before anyone takes them at face value. Hit subscribe if you want to see exactly which claim I tackle next, and smash that like button right now if any single number in this video genuinely surprised you the way it surprised me while I was testing it. I'll see you in the next one.